When Ron Mallett was 10 years old, his father died of a sudden heart attack. He was only 33. For Ron, the world shattered, and he buried himself in books to escape the grief. A year later, he stumbled onto a copy of H.G. Wells' classic novel, The Time Machine. There was a line inside that caught his attention, the idea that time is simply a kind of space, and we should be able to move forward and backward in it. That single thought planted a seed. If time is a physical dimension that can be navigated, then the past isn't gone forever. If he could figure out the mechanics of a time machine, he could go back, warn his father to stop smoking, and save his life. That might sound like a childhood fantasy, but today, Ron Mallett is a highly respected professor of physics who has spent his entire career trying to turn the mathematical equations of time travel into a practical, functioning piece of hardware. Traveling backward is incredibly difficult, but going forward into the future?
That is a solved problem. We actually have bona fide time travelers living among us right now. This is American astronaut Peggy Whitson. Over the course of her career, she spent a record-breaking 665 days orbiting the Earth aboard the International Space Station. This diagram shows what happens when we apply Albert Einstein's theory of time dilation. The laws of relativity dictate that the faster you travel relative to someone else, the slower your clock ticks. Because Whitson was moving at intense orbital speeds for nearly 2 years, her physical timeline desynchronized from ours. The math is exact. By the time her final capsule landed back on Earth, Whitson had aged 2 seconds less than everyone she left behind. She skipped 2 seconds into the future. So dialing the clock forward is just a matter of extreme velocity, but navigating to the past, the only direction that matters for Ron Mallett's mission, requires exploiting the most extreme, untested boundaries of physics. Look at this visualization of what physicists call the block universe. It is the standard model used to understand relativity. In this framework, the past, the present, and the future all exist simultaneously. The dinosaurs are still out there, occupying their specific coordinates in spacetime. If the past isn't completely erased, then time is literally a place, and to get to a place, you just need to build a bridge. Einstein theorized that spacetime could be warped enough to create shortcuts. We know these theoretical bridges as wormholes. Researchers are actively looking for them. In Russia, scientists like Nikolai Kardashev have used a network of massive radio telescopes, essentially creating an Earth-sized virtual dish, to scan distant galaxies for the unique visual fingerprints of a wormhole hidden behind space dust. But locating a cosmic tunnel is only half the battle. The real engineering nightmare is stepping inside one. Theoretical models give wormholes an incredibly inconvenient habit. The moment matter enters one, gravity causes the tunnel to instantly collapse and crush whatever is inside. To prop the mouth of a wormhole open long enough for a traveler to pass through, you need an enormous amount of negative energy, something we don't naturally see in standard physics. This animation highlights a mysterious phenomenon known as dark energy. Normally, the gravity of galaxies should pull them together. Instead, astrophysicists measured that the universe is actually accelerating apart. Something in the empty space is acting as an anti-gravity force, pushing them away. Nobody knows exactly what dark energy is yet, but if we can eventually understand and harness it, it could provide the exact repulsive force needed to stabilize a wormhole and keep a time machine's door propped open. Relying on deep space wormholes is a massive gamble, so physicists are also looking for ways to manipulate time right here in a laboratory. This diagram illustrates Ron Mallett's experimental approach. He theorizes that because light can affect gravity, a high-intensity circulating ring of lasers could act like a spoon stirring a cup of coffee, physically twisting space-time until the linear timeline bends back onto itself into a loop. Other researchers are looking at the subatomic level, focusing on a phenomenon called quantum entanglement. Two particles can be separated by billions of miles, yet they perfectly and instantly mirror each other's movements. Einstein called it spooky action at a distance. Because these particles interact instantly, regardless of the space between them, they communicate faster than the speed of light. And if you beat the speed of light, you beat time itself. In the quantum realm, the rigid one-way arrow of time that we experience every day completely falls apart. It gives physicists a raw blueprint for hacking reality. Even if we source the dark energy, build the lasers, and manipulate the quantum particles, there is a final, non-physical barrier to traveling into the past: logic. This chart outlines the famous grandfather paradox. If you successfully travel back in time and accidentally, or intentionally, kill your grandfather, you erase your own existence. But if you never existed, you couldn't have traveled back to kill him in the first place. You exist, and you don't exist, simultaneously. This contradiction is why physicists like Lee Smolin argue that the block universe model is flawed. Smolin believes time is not a pre-written map we can walk around on, but a continuous, flowing process that creates the future second by second. Yet, despite the paradoxes and the philosophical debates, there is a glaring detail keeping the dream alive. Nothing in the core equations of modern physics explicitly forbids backward time travel. Between the instant communication of entangled particles, the anti-gravity push of dark energy, and the relativity of warped space, the universe has left us a handful of structural loopholes. Time travel is no longer a fantasy confined to the pages of an H.G. Wells novel. Whether we use it to witness the birth of life, skip forward to see how humanity ends, or simply warn a loved one, mastering time is entirely an engineering puzzle, and human history is defined by solving the impossible.